According to Educative 2023, while solving number spiral diagonals, it can be tedious and prone to human errors. And in mathematics contests and in research, every second matters. And one wrong mistake can ruin the whole solving process.
That's where our study comes in. We have recognized that the traditional method for solving number spiral diagonals are inefficient and complex. So our study focuses on developing a quicker and more accurate way in solving it that saves up time, reduces error, and promote problem solving.
Our goal is to create a method that not only simplifies spiral computation, but also enhances mathematical learning and innovation.
Greetings, everyone. My name is Sachio Tsuji.
Michael Jebhard Ancog,
Adrian Ventura.
John Lemuel R. Laxamana.
Rexor Mateusz Sitan,
And Pierre Benedict Serquiña.
Representing
Tayug National High School, Tayug, Pangasinan, Philippines!
And this is our study entitled The Shortcut Formula for the Sum of the Diagonals of a Number Spiral by Consecutive Counting Numbers as a Starting Point.
Our study aims to find a shorter and faster method for calculating the sum of the diagonals in a number spiral using a simple pattern that starts by counting by 9.
To achieve this, we focus on several key objectives. First, we identify the end term of the diagonals in a number spiral formed by consecutive counting numbers. Next, we work on deriving a new formula for finding the sum of those diagonals. Then, we compared our shortcut formulas to the traditional method to test their accuracy, timeliness, and efficiency. Finally, we analyze whether our results match the traditional approach and if our method can truly save time while maintaining precision.
Traditionally, to find the sum of diagonals in a number spiral, one must list and manually add every number in the spiral, a method that becomes extremely long for large matrices such as an 11 by 11 or 21 by 21. Then, identify all of the numbers that is in the diagonals. Middle is included, then add them all together. As you can see, this can be a bit tedious and time-consuming.
To address this, we developed a shortcut formula using consecutive counting numbers as the starting point.
First, we gathered all necessary tools. We analyzed the number spiral starting from 9, identifying the sequences that appear along each diagonal. Using these sequences, we applied finite differences and quadratic equations to find the end term for each diagonal. We then used two main methods, the difference method and the system of equations, to derive our shortcut formulas. Once we obtained all those formulas, we tested them by comparing the results with those from the traditional method. Finally, we evaluated whether our shortcut is not only correct, but also faster and more efficient, ensuring that it truly improves on the old way of solving number spiral diagonals. And this is an example of a 5 by 5 spiral by 2 as a starting point, with the traditional method and with the newly derived formula.
After testing our shortcut formula, the results clearly show its accuracy and efficiency.
We also tested the formula for different starting points, from 1 to 9, and every result matched the traditional method. This confirms that our formula can precisely calculate the sum of diagonals in any number spiral, not only in 1 to 9, but 10 onwards.
In terms of time, the difference was significant. For example, the average time of solving manually for a spiral with 9 as a starting point in matrices of 3 by 3 up to an 11 by 11 took around under 5 minutes, while using our shortcut formula only took about over a minute. Even for smaller spirals, manually solving took over 1 to 2 minutes, while our formula only needed just about a minute or less.
These results prove that our derived formula is not only accurate, but also much faster, making it a more efficient method for solving number spiral methods.
In the end, our study proved that solving number spiral diagonals doesn't have to be complex.
By comparing results with the traditional method, we confirmed that our formula produces the same accurate answer in less time, making it a valuable tool for both research and education.
With this, we hope to inspire other mathematicians and researchers to make a more smarter and more time-efficient formulas in the field of mathematics. And that's the end of our presentation. Thank you!